All right, so we're going to have a look at compound angles. So the first one obviously we're going to do is to prove, and this is the most important one to prove, that the cos of A minus B is equal to the cos of A by the cos of B plus the sine of A by the sine of B. Okay, it's the most important one to prove. Okay, so this is the one we prove. It's the only one that actually needs an actual construction. So we're going to construct a circle. Okay, obviously you'll do this circle a bit better than I will. Okay, that circle obviously has a center, and we're going to, from the center, we're going to create two lines. Okay, and each of these lines has a length of 1 unit. Okay, so I'm going to call this side, I don't know, let's call that one P and that one Q. Now we're going to subtend some angles between here. Okay, so this angle here from there to there, we're going to call that A. Okay, and then this little angle here from there to there, we're going to call that B. So obviously A minus B is in here. So if I was to draw it again, just to show you and visualize it, A minus B is this angle here, because it's the full length of A minus the little bit of B. So that's A minus B, and we still have P and Q here. Okay, so what our strategy is going to be is we're going to find the distance from P to Q two different ways, equate those two different ways, and hopefully arrive at some type of solution for that. Okay, so how do we do this? Well, there's two different ways you can actually work out the distance. Okay, we can use our old friend, the coordinate geometry, get the distance between 2 points, so long as we have two coordinates. And the beauty of the fact that this is a unit circle of length 1 allows us to do that. Or we can use our other old friend, the cosine rule. So I'm going to show you how to do it first using the formula. Okay, so we're going to start by using this formula, x2 minus x1 squared plus y2 minus y1 to be squared. Now, of course, we need coordinates, but we have coordinates P and Q. And P is one of the coordinates, and Q is obviously going to be the other coordinates. But the coordinate of P is just the cos of A by the sine of A from our unit circle. Okay? And the coordinates of Q from our unit circle are just going to be the cos of B by the sine of B. Because again, they're referenced from there. So that one is referenced from B, but Q is referenced from A, the whole of A. So there's our coordinates. So there's your x1, y1, x2, y2. Okay, so we're just going to pop them in and see where that goes. So the length of PQ, okay, is going to be squared, is just going to be, so I'm squaring and getting rid of that square root by squaring it out. Okay, it's going to be x2 minus x1 to be squared, so it's going to be cos A minus cos B to be squared plus sine A minus sine B to be squared. Okay, so unfortunately we have to square this out, but it's an easy one. Square the left, cos squared A, square the right, cos squared B, and multiply them together, minus 2 cos A sine A plus cos squared B. So that's that one then out. Okay, and obviously we're going to do the same thing here. Plus square the left, sine squared A. Square the right, you're going to get sine squared B. And then multiply them together, minus 2 sine A sine B. And don't forget, sorry, I'll just slip that up. Don't forget the sine squared B plus sine squared B. Okay, so that is the hardest line to do out, but it's just using our algorithm. Square the left, square the right, multiply them together and double it. That's all it's using. Now, of course, this all comes together very nicely because I have cos squared A plus sine squared A. And that's an identity. Minus 2 cos A cos B plus, what have we got, sine squared B, minus 2 sine A sine B. So all I've done is taken out a thing I know to be true. okay, because I know that's an identity, okay? And I also, like, that's the beauty of this, okay? Have I missed anything? Cos squared A, sine squared A, sine squared B, cos squared B. Oh, there's a cos squared B there. Sorry, I forgot about that. Okay. I can't have enough space here, so I'm just going to write it here, plus cos squared B. Okay, and you can see that, look, cos squared A and cos squared B and sine squared A and sine squared B, you can see that they're both 1. Okay, so that's going to be 1 plus 1 is 2, and then what we're left with is this, all this bit and this bit here. So look, minus 2 cos A cos B minus 2 sine A sine B. That's what we're left with when we take out this, this, and this, because they are both 1. Okay? Now, when you look at that very carefully, I can factorize the minus 2 out of that. And because I'm factorizing the minus 2, that becomes a plus. So there I have it. I've factorized that out. Now you're thinking, can I do any more? You don't need to do any more, because that's the first one done. Okay, you've equated, that's the distance. Okay, so you've worked that out. You've gotten the length of it squared. Okay, so all I need to do now is find this using the cos squared to make the two answers equal to each other, and hopefully it'll work. Now, if I use the cos squared, if I use the cosine rule, well, cosine rule says that opposite squared, in other words, PQ squared is equal to the other two sides squared and added. So think about it. It's going to be 1 squared plus 1 squared minus 2 times 1 by the cos of the angle in between it. Okay? And of course the cos of the angle in between it, the cos of the angle in between it, there's the angle in between it. You see where we're getting this from. Okay? So look, let's do this out. That's going to be 2 minus 2 cos A minus B. So now I have my two formulas. I'm going to make them equal to each other. Okay? I'll take the first one. So that's 2 minus 2 cos A cos B plus sine A sine B. And I'm going to make that equal to 2 minus 2 cos A minus B. Can you see what's happening here? That 2 cancels with that cancels with that, and what are we left with? We're left with the cos of A minus B. I'm just rearranging it, so this is this side and that's that side. The 2's are gone from everything, and you're left with cos A cos B plus sine A sine B. And there you have your proof. And you need this one to do all the other ones that we're going to do, apart from the last one. This covers all the other ones don't work unless this is true. It doesn't mean you're going to be asked it, but it does mean that you need to know how to do it. Okay? So let's have a look at the next one then. So because this is true, a number of other things are true. Okay? So just so you know, these identities would be true because of that the cos of a negative angle is the same as the cos of the positive angle. Okay? The sine of a negative angle is minus the sine of the positive angle. And you can then compound them. Watch. The sine of 90 minus an angle is the same as the cos of that angle. And the converse, the cos of 90 minus an angle is the same as the sine of an angle. Those two are particularly handy. Okay, so let's prove our next one then. If I want to prove that the cos of A plus B is equal to the cos of A by the cos of B minus the sine of A by the sine of B. This one is a tricky one, so you have to know the trick. Okay, the trick is to replace this B with a minus B. Okay, so watch. That really becomes now the cos of A, because we know that the cos of an angle is the same as the cos of minus an angle, so I'm allowed to do this. Now, I'm saying that that's still true because we've proven that this is a plus version. That's why I've changed that sign there. This is the plus version, okay? But now let's separate it out, okay? Let's separate it out. Let's pop that minus in there. So you see what I'm done here, okay? This we just proved. We know this is true. But if I replace this b with the minus b, but I don't turn that into a plus. See, I haven't turned it into a plus. I've kept it as a minus. Let's see what happens when I distribute it here, okay? I'll get the cos of a by the cos of minus b plus the sine of a by the sine of minus b. Okay, now what does our rule say? Well, that really means that that's minus b is the same as b if you're getting the cos of it. And what does that rule say? It says, well, if there's a minus b as the angle, pop the minus in front of it. And if those two are minuses, let's make them a plus. And is that not what we would be asked to get? And there you have that one done. Okay? Very, very similarly, if I want to prove that the sine of a plus b is equal to sine a cos b plus cos a sine b. So in other words, the opposite version of this. Now that's the cos of the two of them added, the sine of the two of them added. You can already think what we're going to do, okay? What we're going to do is we're going to use our original identity, the cos one. We know that the cos of a minus b is this. Okay, we know that's true. We're going to replace one of them with one of these identities because we want to get the kind of, we want to get the a in there, you know what I mean? So we're going to replace it. So watch. That's going to become the cos of 90 minus a minus b. Okay? And that's going to be equal to, now we're going to pop this in everywhere a is meant to go. So that's going to become the cos 90 minus a by the cos of b plus the sine of 90 minus a by the sine of b. Okay, so you see what I've done? I've just replaced that, and you can see what's going to happen even before it happens. Okay, so if you look at it here now, the cos of 90 minus a, if I go back up and look, is just the sine of a, which is what I want, by the cos of b, plus the sine of 90 minus a is just the cos of a by the sine of b. And you're thinking to yourself, okay, that's that bit, but what about this bit? Well, look, let's look at it very carefully, okay? The cos of 90 minus a doesn't work. But if I make that the cos of 90 minus, and then take the minus out of that, well, you can see what that is. That's really the cos of 90 minus an angle, which is just the sine of that angle. So that's really just the sine of a plus b. And that's that one done. That one is a little bit trickier than that one. That one's a bit more straightforward. Okay, so for the cos of the plus versions, you sub a minus in to the sine of a minus b. Both of these start with the cos of a minus b, or a generic formula. In one case, you sub a minus b in. The other case, for the a, you sub in a 90 minus a. Okay, and apply them accordingly, and then look for changes. Okay, so that's those two done. There's only two more to kind of worry about. Okay, this one is a two-liner, basically. If you want to prove that the cos of 2a is equal to the cos squared a minus the sine squared a, well, cos of 2a is really just the cos of a plus a. So the cos of two angles, a plus b, we know that's just going to be the cos of a by the cos of b. In other words, cos of another a. We're pretending this is meant to be a plus b, if you think about it. Cos of a plus b is really the cos a cos b plus sine a sine b, or sorry, minus sine a sine b. But because we have no b, we just got two a's. And of course, what happens when you multiply the two of them together? You've got cos squared a minus sine squared a. And then a plus a is 2a. There's your proof. Can't be any quicker than that. It'd be lovely if that was the one that turns up. And of course, here's our last one then. Okay? So, to prove, there's loads of different ways of doing this. I'm going to show you the most way that'll guarantee you that it's right no matter what. Okay? And this works with the plus or the minus version. Tan of a plus b is equal to the tan a plus the tan of b over 1 minus the tan of a by the tan of b. Okay, so how do we do it? Okay, well, it's very simple. We just expand the left. Okay, so tan of a plus b is really the sine of a plus b over the cos of a plus b. And of course, what is the sine of a plus b and the cos of a plus b? Well, again, we know what a plus b is because we just proved it. Okay, sine of a plus b is sine a cos b plus cos a sine b over, well, what's the cos of a plus b? Well, we just proved it. That's just cos a cos b minus sine a sine b. And your t-step, what do I do next? We're going to divide both sides by the bottom. Okay, so watch. That's going to be sine a cos b plus cos a sine b. I'm going to make a little bit of space. Okay, I'm going to write this bottom line down. So look, I just put a bit of space to put something underneath it. Okay, same here. Cos a cos b minus sine a sine b, and making a little bit of space. So you see what I've done? That's your original fraction. There's your original fraction, okay? And now I'm going to create a new fraction, top and bottom, okay? So that's all I'm going to do. All I'm going to do, it's as simple as this, okay? Is I'm just going to divide everything by cos A, cos B, okay? So my idea here is it'll start cancelling stuff, okay? So watch. Cos A, cos B, cos A, cos B, cos A, cos B, cos A, cos B. And then figure out what it does. Okay, watch. Cancel, cancel. Sine over cos is tan of A. Plus, cancel, cancel. Sine over B over cos of B, tan of B. Over cos A over cos A, cancel, cancel, that's 1, minus sine A over cos A is just tan A, sine B over cos B, tan B. Is that what I'm asked for at the very start? Tan A plus tan B over 1 minus tan A, tan B, QED, you're done. And you can do the exact same thing with tan A minus B. It works exactly the same way and you're done.